Hi everyone, and welcome back to part 3 of Project Cipher, the new PC build. So here it is, all running. Bit of a struggle to get to this stage, more on the technical side of things rather than the physical build. However, we got there in the end, and as I alluded to at the end of part 2, yes, there was some technical issues. So after doing the build and I went to run Windows, or install Windows I should say, I ended up with nothing but random lockups, hang-ups, you name it. And it turned out in the end, after a bit of diagnosing and swapping RAM sticks around and things, I actually had a faulty RAM stick. So I contacted the supplier over in Limassol and they gladly swapped it out with no issues. So we did manage to get all the system running. And this took us into the next problem, was the RAM configuration. So with the DDR5, the rated speed of these Corsair Dominator titaniums is 6600 megatransfers per second, and if you do a search on the internet you will find that it is very difficult to get anywhere near that speeds when you're running in a 4-stick configuration. And unfortunately you cannot get 64 gig DDR5 sticks easily on the market, so that's why I have got the 432s. So they're not running at the full 6600, I had to downclock them to 4800 to get a stable system. So that's where we are at the moment until the motherboard or the chip manufacturers can get some alignment on optimization of this configuration. Now this isn't limited to the Asus ROG motherboard or to the Corsair RAM sticks. It's a general industry issue with the DDR5 configurations. So anyway, we've got a good system, it's running, it's stable at 4800. The other issue then we had was on the actual software side of things. Countless problems with the controller software for the various bits of kit in the system, particularly the Armory crate for managing the LED etc. on the motherboards and the ROG gear, and also the IQ Commander software from Corsair. Don't know what was going on, conflicting between the software, hardware issues or whatever it was, but it kept giving me random issues. And also found that the IQ software also caused some conflict with the NVIDIA drivers, and no matter what I did, problems, and I couldn't get the LED or the RGB set up how I wanted it, and as I say, it kept crashing the software, which wasn't so good. So in the end, uninstalled all that software, went to look on the internet for an alternative control software, and this is where we're running now. So I ended up downloading Signal RGB, which is an all-in-one package. The free version doesn't do PC cooling, so I did actually pay for the pro version, which is not very much, just a couple of dollars a month or whatever it is, but it does give me full control of everything on the system, with the exception of the Dominator titanium RAM sticks. They are not currently supported, and I dare say that'll come along in time. So as you can see on the screen, we've got this scrolling green, blue, up and down pattern, and then all these individual components relate to the various RGB modules on the hardware side of things, and that's how we managed to get the whole system synchronized, obviously with the exception of the RAM, which is still currently showing the red, which was a leftover profile that I had in before I uninstalled the IQ software. And then for the CPU cooling, I've got the NZXT CAM software, and that's working fine, no problems. And I've got all the cooling profiles set up for that as well. So I'm using the all-in-one pump is kept at a maximum fixed speed, and then the fan cooling comes in based on temperature. And then on the Signal RGB, as it's the Pro version, I can set up cooling profiles for it as well. And I've got all the different fan combinations set up for different parts of the system. So for example, when the CPU gets loaded up, certain fans will kick in to feed air through the top CPU cooler. And then when the GPU spools up, different fans will kick in to feed cold air into the GPU. and then the exhaust fans at the back of the case will also spool up to take the heat out of the case because it's an internally venting GPU, and everything appears to be working good. So I'm still playing with the fan curves, trying to balance the noise versus temperature, and that'll take a bit of time just to try and get that all stable. And the other thing I'm trying to do is, while the fans are operating at the different points in the curves, is trying to maintain positive pressure inside the case to minimise dust intake. So that's that. So what we're going to do now in part 3 of this video is we're actually going to do some benchmarking on the system. So what I've got is my two systems set up side by side. I'll turn the camera around for doing the actual benchmarks. And what I intend to do is, on both systems I'll run the same benchmarks. I'm going to disable one of the screens so that both machines are only operating with one screen. And then I'm going to run some standard industry benchmarks, so CrystalDiskMark for the SSD, Blender, Cinebench R24, and then we'll do some of the astrophotography benchmarks. So for example, we'll run the PixInsight benchmark. I will then also run some of the tools within PixInsight using the same base image. For example, do BlurXTerminator, StarXTerminator and NoiseXTerminator, and just to see what the time differences are between my old and the new systems. Alright, so let's get into that. Alright, so this is how I'm going to set up the benchmarks. I'm obviously not going to record all the individual screens because they'll take a bit of time to run some of these benchmarks, but just to give you the general flavour, I've got the old PC here on my right and the new PC here on my left. Both screens are set to full 4K resolution and the scaling is set to 150%. And the first test I'm going to run is CrystalDiskMark, which is version 8.0.4, and I'm going to run it on the SSDs on the new system, both of them, although they're both the same disk, make and model and capacity. And then I'll also run the two individual disks on the old machine, which are slightly different models, the 970 Evo and the 970 Evo Pro. So let me get on with that. Okay, so the CrystalDiskMark is finished on all 4 drives, and just very roughly, the new machine is running around about 7 gigabits or gigabytes per second on a sequential 1 meg read, and the writes are almost again 7 gigabytes per second, and the old machine has got a read of just over 3 gigabytes per second and a write of 3 gigabytes per second. So I'll put all the full numbers at the end. Alright, so the next benchmark we'll run is Cinebench 2024. I will run all 3 different benchmarks, so that's the GPU, the CPU multi-core and the CPU single core. Just the standard tests I'm running, which I think are a 10-minute duration each. And we can see straight away that the new machine has finished one scene already, and the old machine is still finishing up the first render. So the GPU renders have completed, and the score for the new system came in at 26,684, and it completed 49 passes of the rendering. And the old system came in at 9,710, which completed 18 passes of the render. And it is one thing to note is the GPU on the new system is actually scoring lower than I have seen it previously, and this is, I think, down to the different memory configurations. So when I had it running with 2 sticks of memory at 64 gigabytes instead of the current 4 sticks of memory at 128 gigabytes, the score I was seeing was around about the 34,000 mark. So I am taking a performance penalty with the different memory configuration, and there may be also some thermal throttling still in there due to my cooling profiles. Okay, for the next benchmark we're going to run Blender, and that'll be version 4.0.0, and again I'll be running 2 tests. So we've got the CPU test and the GPU test. So the first one we'll do is the CPU. So the new computer is obviously running the Core i9 14900K, and the old computer is running the Core i9 7920X. So let's go. Alright, so the Blender benchmarks have both completed for the CPU and the GPU. And for the CPU, the new computer came in at 520 versus the old computer at 208. So the new one's 2.5 times faster. And on the GPU, the new computer came in at 11,415 and the old computer was 830. So that's 13.7 times faster for the new computer. Quite a difference. Right, let's move on to some astrophotography related benchmarks, and we'll obviously fire up PixInsight. So as we know, those who use PixInsight, it takes quite a while to load sometimes, so I'm going to fire them both up hopefully at the same time here, and we can see just the load time difference on the old machine versus the new machine. So as a reminder, the new machine is the one on my left screen here. And let's go. And the new one is finished. And the old one is finished. So yeah, quite a difference just on startup times alone. Alright, so in PixInsight, the only changes I've made is on both machines. In the global preferences, I have gone in and tweaked with the parallel processing in threads. So on the new machine it's set to 32 and 32. I don't yet know what the optimum number is on that machine. And likewise on the on the directories and networks, I've been playing around with the number of swap folder references. I think I've got 29 set in here. And on the old machine, the parallel processing and threads are set to 24, and the swap files are, I think it's around about 21. So these numbers are obviously, or these references are still to be tuned, but I think they're best as I can get them for the time being without spending a huge amount of time. So let's fire up PixInsight benchmark. Alright, so we've got the PixInsight benchmark open. And I will try and do them at the same time. So let's run benchmark. And I missed the one on the new machine. Never mind. Alright, the new machine has finished. It's come in with a total score of 29636, a CPU score of 31999, a swap file score of 22814, and a transfer rate of 4119.149 megabits per second. And the old computer has just finished. It's come at a score of 13154 for the total, 12857 for the CPU, 14630 for the swap file, and 2641.44 for the transfer speeds. Okay, so the next thing I'm going to do is I'm going to load up a reference image into both machines. So this is an exact same copy of the same image that I've got sitting over on my NAS box. So this is NGC 896. And we'll fire it up on the other one as well. This was a live stack that was taken directly out of PixInsight live stacking on my Astro rig number 1 in the observatory. So if we do a quick screen transfer on here so you can see what's there. Okay, so we've got the same window open on each. Both machines, I forgot to say earlier on, was they're all fully patched windows. They're all running the latest version of the NVIDIA drivers. It's a fully patched latest release of PixInsight with all its updates applied, so they're all exactly the same build effectively. So the first thing we're going to do is we're going to run a NoiseXTerminator on both, and I can pick up the data from the process console on each of them. So as I say, we'll run the three of them. So the first one I'm going to do is NoiseXTerminator. There we go here, and I'm going to run it with the default settings, and this is also the latest release of NoiseXTerminator, so AI version 2, and we will execute both of these together as well if I can. Okay, so they are both finished, and for NoiseXTerminator the metrics being reported are swap speeds of 3297 megabytes per second for the new machine and 2046 for the old machine, and the execution time was 10.464 seconds on the new and 21.884 seconds on the old. So again, pretty consistent, twice as fast on the new machine. So now that we've run NoiseXTerminator on there, let's do the next one, which is going to be BlurXTerminator. Again, we'll run that at its default settings, and this is also running the latest version, so that's version 2 with AI version 4. The new one finished it in 35.842 seconds, and the old one is still running, and that's it finished, and it took 1 minute 1.36 seconds. Okay, for this next test we're going to run StarXTerminator. Again, we've got the latest version, so it's 2.2 running AI version 11, and we're going to generate a star mask I should say, and let's get ready and let's go. The new one took 27.074 seconds, and the old one took 44.181 seconds. So what I'll do as well is I'll put a link to the file I used for those three tests into the description, so you can always download that and compare it against your own computer's PixInsight install and hardware setup. Alright, so the next test I'm going to do is the weighted batch pre-processing script, and for this I've loaded in the Fishhead Nebula, 121 light frames, 30 flat frames and 30 dark flats. I have set the preset to faster with good quality on both of them, and we'll see how this runs. I have also turned off astrometric solution and I've turned off auto crop. So we'll let this run and see how long it takes in each. Alright, so WBPP has finished executing the script on both machines, and the old computer took 59 minutes 12 seconds to complete the task, and the new one, it took 25 minutes 24 seconds. So again, just over twice as fast in total. And the image that came out, here we have it, all done. So you could go and process that image. Alright, and for the next benchmark we're going to take a look at video encoding. So I am using the project part 2 video as the baseline for this. So this is in Shotcut, my video editor of choice, and it contains around 25 gigabytes of source files. 4K 60 is the video format, and I'll export it to an H.264 file, and I'm using the automatic detection of the hardware encoders, and we'll see how long it takes in each of these. Alright, so that's both the machines finished encoding that video. So that was a 4K 60 FPS video output, and the old computer took 47 minutes 28 seconds and produced a video file 16.5 gigabytes in size, and the new computer, it produced that video in 18 minutes 40 seconds and it was 14.7 gigabytes in size. So there you have it. Alright, so that'll wrap us up for the end of this project, and we'll maybe see you in the next 5 years for the next build. I dare say it'll be quicker than that, knowing how fast technology is advancing, but let's just wait and see. So anyway, I'll leave you with all the specifications and the benchmark slides, etc., just so you can see, and also put the links to the project files down in the description. So that's for the PixInsight images that I used for the benchmarking. And yeah, that was quite an enjoyable project despite the problems, and I dare say we'll continue to get some good use out of this machine and the old one for some time to come. So on that note, thank you very much for watching, everyone. Don't forget to hit that like if you liked the video, and I really appreciate any subscribes as well to continue to grow the channel. So we'll catch you in the next time, and hopefully we'll get some clear skies soon so I can get back to doing some astro imaging. We'll see you later.
So high I'm hypnotized. What's up is down, what's left is right. Chasing stars and holding you. I can't see the end, but we'll see it through.